So let's begin with the chapter number system. To start off, the following pictorial representation of the types of number will help you improve your quality of comprehension of different types of numbers. So here you people can see that real numbers are basically divided into two groups, that is your decimals and your integers, that is numbers having no decimals, right? Then your decimals are then divided into two other groups, that is finite or terminating decimals and infinite or non-terminating decimals. And your integers are divided in three groups, that is your negative ones, your zero and your positive ones, right? Your zero and your positive ones are termed as your non-negative integers, whereas your negative integers are termed as your non-positive integers, right? Then your finite or terminating decimals have these examples. Your infinite or non-terminating decimals have these examples, irrational numbers and all that sort. Then natural numbers are subdivided into three categories, that is your unity, your prime number and your composite numbers, right? So all this is what we are going to study and what we are going to learn step by step, building on the number systems. So let's start. The first thing is, what are natural numbers? Now in this chapter you people are going to see that there are so many definitions and so many small things which you need to read, which you already know. Like for example, you people know what are real numbers, you people know what are natural numbers, what are whole numbers, what is zero, what is one, what is prime, what is composite. Now where does the problem come? The problem comes that sometimes we people mix these things, alright? So it's very important to understand what these things are, to minutely read the definitions of all these things and then do the questions. Questions are important, no doubt, but do not mix the definitions, do not mix the concepts. Okay. So when I come to natural numbers, what are natural numbers? All positive integers are natural numbers. Okay. There are infinite natural numbers and the number 1 is the least natural number. And what are examples of your natural number? 1, 2, 4, 8, 32, 3, 7, 10, 11, 20, 17, 99, 100, 4, 3, 2, 1 and so on. So there are so many examples of natural numbers. Now based on the divisibility, there could be two types of natural numbers, okay? So the two types of natural numbers can be prime numbers and composite numbers, okay? So there are two types of natural numbers, this you have understood. One is your prime and the other one is your composite number. So let's understand what are prime and what are composite numbers. So prime numbers. So what are prime numbers? A natural number that is larger than unity is a prime number if it does not have any divisor except for itself and unity. Now the thing is, you people know that what are prime numbers, right? But the one most important thing which you need to actually underline here is that unity is not a prime number. Now when I was, I do not know in which class, probably third or fourth, when the concept of prime numbers is taught for the first time. At that point of time, when my teacher taught me that, okay, what are prime numbers, the first question that arose in my mind was that, is one a prime number? Like, or is it not a prime number? Because the thing is that they are saying that the number is going to be what? The number has to be larger than unity. Now, I did not know the concept of larger or equal to or less than or equal to or anything like that. Okay, I did not know the concept of these things. But the thing was that because it was said that it should not have any other divisor except for itself and unity. Now, obviously, 1 is divisible by itself. And because 1 is unity, then it's divisible by unity. The thing is that 1 and unity is one and the same thing. So, for 1, these two concepts merge. Okay, so I was like in a dilemma whether 1 is prime number or not. So my teacher taught me that, okay, 1 is not a prime number. Mathematicians do not consider unity, that is your 1, in your prime number category. Okay, so now let's study some of the properties of prime numbers. Now in this chapter, you people will see that the questions are easy, but the thing is that if you know properties of some things, like for example your prime number or your composite number or your co-prime numbers, whole numbers, real numbers, so if you know small properties which are very basic, then you people can solve the questions very easily and very readily. Okay, so let's read what these properties are. Okay, starting from first, the lowest prime number is 2. Okay, so the lowest prime number is 2. and 2 is only even prime number. Why? Because any even number which is greater than 2, that will have 2 as a factor. So which means it cannot be a prime number in that case. Next is the lowest odd prime number is 3, because obviously any multiple of 3 is going to have what? Like basically what they are saying is lowest odd prime number is 3, because any multiple of 3 will have 3 as a factor, and all the prime numbers which are odd other than 2, obviously 2 is the only even number, even prime number, and other than 2 all of them are odd, and the smallest out of them is what? 3. Then the remainder, when a prime number, any number which is greater than 5 is divided by 6, is 1 or 5. So this is one of the property which you people need to learn, which you people need to understand. What they are saying is that whenever a prime number that is greater than 5 is divided by 6, like for example, if I take a very simple example. Now 7 is a prime number. If 7 is divided by 6, so what is going to be the answer? 1. Okay. If 7 is divided by 6, it's what? 1. And 13 is also a prime number. If 6 is divided by 13, then what is going to be the answer? 1 again. 17 is also a prime number. Correct? 17 is also a prime number. So if 6 divides 17, what is going to be the answer? What is going to be the answer? 5. Right? So this is basically what this property says. So this property is easy. If you people do not understand any property like as in its definition format, then do take examples. Like for example, I have taught you this property with the help of an example. So what you people need to do is you need to take real life examples. Like I've taken these real life examples. So your people should take these real life examples so that you can understand these properties in a better format. Okay. So what is next? It says, however, if a number being divided by 6 gives a remainder 1 or 5, the number need not be prime. This is true. What they basically want to say is ki seedha this is applicable, but reverse mein it's not applicable. Okay, this is true. Like for example, we can say that Earth revolves around Sun, but Sun does not revolve around Earth. Okay, so these two examples doesn't like coincide or something like that, but I guess you people understood what I want to say. So what is next? Thus, this can be referred to as a necessary but not a sufficient condition. I hope you people have agreed, because like in reverse order it's not true. Therefore, the example which we are taking, or you can say the condition which we are considering at this point of time, that condition is necessary, but it's not the sufficient condition to conclude anything. Next is the remainder of the division of square of a prime number which is greater than 5 divided by 24 is 1. So what it's trying to say is that if there is any prime number which is divided by 24, then the remainder of that division, okay, of square of prime number, okay, basically what they're trying to say is the remainder of the division of square of prime number. Okay, for example, there is any prime number p, and if I take that p has to be greater or equal to 5, right? So if I take any prime number which is p and p is greater or equal to 5, then the square of that p when divided by 24 is going to yield me what? Remainder as 1. This is one of the property. Okay, so I feel these properties are simple. You can, elaborate these properties as well, or you can take real life examples into understanding what these properties say. So let's move forward without further ado. Okay, then it says that for prime numbers that are greater than 3, the square of that prime number minus 1 is divisible by 24. Okay, next is all the prime numbers between 1 to 100 are these, prime numbers between 100 to 200 are these, and 9 and 10 property is very, very important. What does it say? It says A and B are any two odd prime numbers. Suppose A is 3 and B is 7. Okay, so A square minus B square has to be composite. Let's suppose 3 is B and 7 is A. So A square is 49 minus 9 is 40, and it's a composite number. And also A square plus B square has to be composite. So if I add these two, that is 49 plus 9. It has to be what? 58. It's also a composite number. Simple. So that means A square plus b square and a square minus b square has to be what? Both has to be composite. Next is the remainder of the division of square of prime number, which is greater than 5 divided by 12 is 1. What it wants to say is that if there is square of a prime number which is greater or equal to 5. So suppose I take any prime number which is greater than or equal to 5 and I square it. Okay, I square that number. Suppose I take 5 and I square it. So what will be my answer? 25. Now if I divide 24 by 12, will my remainder be 1? Of course, because 12 2 is 24. So if 24, so 2 pe 24 ho jayega and 1 is going to be the remainder. So this is also true. So I hope you people understood that what is a prime number and then what are the properties, some of the properties of prime number which I have told you. Now why these properties are important is because sometimes what's going to happen is, suppose you people have learned, the prime numbers between 1 to 100. Now because you people know all the prime numbers between 1 to 100, you can easily do any question which involve these prime numbers, because you do not have to again and again calculate that, all right, what are the prime numbers between 2 to 100. Suppose in a question it's given that, okay, 59 is the prime number. Then you do not have to divide 59 by all the numbers which are smaller than 59 in order to see if 59 is a prime number or a composite number. Okay, you need not to do it. So that is why if you people can learn, then it's fine. If you cannot learn, then I will suggest that learn a few. Like if you cannot learn between 100 to 200, then just try to learn between 1 to 100, because these are the basic ones. Okay. And rest, all these 10 properties which we people have studied so far, these properties are pretty simple, pretty straightforward. So if you people have any query regarding these properties, what you people can do is, you can take a real life examples with numbers, how I have taught you right now, and then you can solve and understand these properties. The thing is, how these properties were generated. Now obviously mathematicians had a lot of theorems and all those kinds of things, by the help of which they actually proved these all things. But right now it's not important to us to actually know how these properties were derived. Right now it's not important to understand that how these properties originated and how the mathematicians actually discovered, or you can say invented, all these kinds of things. Okay, this is not important for us as far as CAT is concerned, as far as any MBA exam is concerned. Okay, so just focus on the stuff which can fetch you marks, because you people have less time. Obviously, you do not have eternity to actually prepare for your CAT exam. You people have less time. So do not waste your time in actually studying the stuff that is not important. What is important is these properties. And with the help of these properties, you can do a lot of questions. So just keep in mind that you have to only do that. Do not go beyond it. You can go beyond it after you finish your exam, or you can say after you have cracked your exam. So let's move forward. Now to check whether a number is a prime number or not. Now the thing is that I've told you all the prime numbers between 1 to 100 and 100 to 200. But what about numbers that are beyond 200? Or if I may say, what about the numbers which are even between 1 to 200, which I do not remember? Suppose 17 is a prime number and I forgot that, okay, 17 is a prime number. Then how to actually see that whether 17 is a prime number or a composite number, what to do in that case? So what I need to do is, I need to take the square root of the number. So there is this illustration which I have given. What I'm going to do is, I'm going to read these steps and side by side see the illustration as well for better understanding of you people. Okay. So what are they saying? That take the square root of a number. Now suppose the number is 239. I have taken square root of that number. Correct. Then it is round of the square root to immediately higher integer. Call this number z. Now the thing is that 239 lies between 15 to 16. Hence the value of z is going to be 16, because they are saying that you have to call that number c, which is like the immediate higher integer. Okay. Now for example, if you have to check for 181, they have given the example itself. So if you need to check for 181, then the square root of it is going to be 13. So z is going to be in that case what? 14, because you need to take immediate higher integer. Okay. Now check for divisibility of number n by all prime numbers which are below that number, that is z. There is no prime number below the value of z which divides n, then the number is your prime number. So basically what they are trying to say is, they are trying to say that suppose you have taken a number and that number in this example is your 239. Okay, and now you have to check that whether 239 is a prime number or it's a composite number. So what you need to do is, first of all, you need to take square root of 239. Now square root of 239 is somewhat between 15 to 16. That means you have to take your immediate higher integer. Now immediate higher integer between 15 and 16 is obviously 16. So your z has to be 16. Now what you need to do is, you need to write all the prime numbers which are less than or equal to 16. So all the prime numbers which are less than or equal to 16 are 2, 3, 5, 7, 11 and 13. And now I have to check that whether 239 is divisible by these numbers or not. If it's not divisible by any of these, then it's a prime number. If it's divisible by any one of these, then it's not a prime number. In that case, it's a composite number. So when I divide 239 by 2, 3, 5, 7, 11 and 13, I found out that it's divisible by none of them. That means what? That means this is a prime number. Hence concluded that 239, the number which I took initially, is what? It's a prime number. So this is how you people are going to check whether a number is a prime number or not. Correct. Next is what are integers. Now right now we have studied about what are prime numbers. So let's discuss on what are integers and then we'll move forward to other stuff. So now what are integers? Integer is nothing but a set which consists of natural numbers, negative numbers and 0 is what is integers. Okay, so what are integers? Integers have your negative numbers, they have your 0 and they have your positive numbers. Okay, so all these things when combined, they form your integers. That means what? When I am going to draw your number line, so on your number line there is going to be 0, there is going to be your positive numbers and then there are going to be your negative numbers as well. Okay. So all these numbers are what? They are integers. So this is approaching to positive of infinity and this is approaching to your negative of infinity in other direction. So all these numbers are what? All these numbers are your integers. Now the numbers belonging to this sets are called your integers, and integers can be visualized on a number line, as I have shown you right here how you can actually visualize integers on your number line. Now one thing that is very important is that positive integers are same as natural numbers. Okay, if I say that these are my positive integers, because these are my positive integers, right? So these are nothing but these are my natural numbers, and natural numbers plus your 0 is going to give me what? Whole numbers. So whole numbers. Okay, moving forward, we have a concept that is called what are your composite numbers. So let's see what are composite numbers. Now, it's a natural numbers that has at least one divisor different from unity in itself. Just right now, before your integers, we basically studied what? We studied prime numbers. So in prime numbers, I told you that the divisor has to be number and unity. Now the thing for composite number is that any number is a composite number if it has at least one divisor which is anything other than unity and number itself. Then that is going to be your composite number. Now every composite number n can be factored into its prime factors. That is true. If I take 4, 4 can be written as 2 into 2. If I take 9, 9 can be written as 3 into 3. If I take 10, 10 can be written as 2 into 5. So what they want to say is that every composite number can be factored into its prime numbers, into its prime factors actually, not prime numbers. Now this is sometimes called your canonical form of a number. That is what? Now n is your any number and there are going to be prime numbers which when multiplied are going to yield that composite number. So all those prime numbers are termed as your factors of that number. Okay. So P1, P2, Pk are nothing but they are prime numbers which are also called the factors of these numbers, and M, K and N are nothing but they are your natural numbers. Okay. M, K, all these things, these are like your powers, exponents of these numbers. Which is to say, like for example, if I take 12, 12 is nothing but 6 cross 2. 6 is nothing but 3 times 2 into 2. So 12 is nothing but 3 into 2 times 2. So this power is nothing but it's going to be your natural number. Okay. So that is what your composite number. So I hope you people understood what are composite numbers. Here some examples are given, like for example your 24 is given and your 84 is given. Here dot does not mean decimal. I hope you people know it does not mean decimal here, it just means multiplication. Now this representation of composite number is called your standard form of a composite number. So this representation is called your standard form. This one is called your canonical form. So it's as simple as that. It's one and the same thing, just the names are different. You do not have to remember the names, you just need to remember how, like in how many forms you can represent a number. Whether it's your prime number, whether it's a composite number, what are integers, what are whole numbers, like the basic definitions and the basic differences, the basic properties of these numbers, so that when you're solving anything, then that thing becomes easy. Alright, so let's move forward. Now we are going to study that what are decimals. So when I come to decimal, what does come into my mind? Obviously a point. Okay, so what is a decimal? A decimal number is a number with a decimal point in it. So any number which has a decimal point in it is a decimal. Like I have given some examples here, that is 1.5, 3.21, 4.173, 5.1, etc. Now did you notice one thing? When I said 3.21, I said 2 and 1 in different numbers. I did not say 3.21, because this is not the way we say numbers that are after your decimal. So all the numbers after your decimal has to be considered individually. I cannot say 3.21. I have to say 3.21. Correct. So the number to the left of the decimal is ordinary whole number. Like for example, if I take 1.5, so in this case 1 is going to be your whole number and 5 is going to be your decimal part of that number. So the first digit to the right of decimal is one's number of tens, the second number of hundreds, and so on. So for the number 5.1, it's a way of writing 5 into 1 by 10. Or you can say 3.27 is nothing but 3 plus 2 by 10 plus 7 by 100. Now how is this possible? It's very, very simple. Okay, if I take 5.1 as an example, then obviously this is nothing but 5 plus 0.1. Okay, so 5 plus 0.1, can I write it as 1 by 10? I can write it as 1 by 10. So it's going to be nothing. If I take it as 50 by 10, 51 by 10, and if I form this in mixed fraction form, it's going to be what? 5 1 by 10. Correct? So this is the way in which you people need to write decimals, and this is what basically decimals are. You can do the conversions. It's simple mathematics, very, very simple. Okay, so moving forward, what do we have? We have whole numbers. So I feel you people know what whole numbers are. It's simple. I've told you this, what whole numbers are before only. So चलो एक बार फटाफट से रिवाइज कर लेते हैं without further ado. So what are whole numbers? Now the set of numbers that includes all the natural numbers and number 0 are what? Your whole numbers. Now whole numbers are also called your non-negative integers, because what? See, your natural numbers are all the numbers which are your integers and which start from 1, including 1. Okay, now if I add 0 to my set of natural numbers, what am I gonna get? I'm gonna get whole numbers. So whole numbers are nothing but they are natural numbers plus your 0. That is what? That is your whole numbers. Okay, now the concept of number line. I have told you what number line is. So this is what number line is, on which you can represent your numbers. So this is your positive infinity approaching to your negative infinity. Okay, so the concept of number line. The number line is a straight line between your negative infinity on the left to your positive infinity to the right. Now the distance between any 2 points, so the distance between any 2 points on number line is obtained by subtracting the lower value from the higher value. Okay, now alternatively we can also start with the lower number and find the required addition to reach the higher number. Okay, now what they are basically saying is, suppose there are 2 points, 7 and -4, and what do I want to do? I want to find out the distance between these 2 points, that is 7 and -4. So according to the literature which is provided here, what they are saying is if I want to find the distance between any two numbers, then I have to write the larger one first, then I need to subtract the lower number from the larger number, which lower number is -4 in this case. So what I'm going to do is I'm going to write 7 minus of my lower number. So my lower number is -4. So I'm going to write -4 here. So it's going to be what? 7 plus 4, that is nothing but 11. So 11 is your distance. Distance between what? 7 and -4. So this is a distance. Okay. So this is what the concept of whole numbers are. Now let's move forward to the concept of your real numbers. So can anybody tell me that what actually are real numbers? Real numbers are nothing but what? All numbers that can be represented on number line are real numbers. Every real number can be approximately replaced with the terminating decimal. So okay, let's review. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8. Whole numbers are natural numbers plus 0. Integers are your whole numbers plus your negative numbers, that is -1, -2, -3. And when I say whole numbers, it's 0 and natural numbers. Natural numbers means 1, 2, 3, 4 and 5. Now what are real numbers? अब ये real numbers का concept कहाँ से आ गया? सारे numbers तो हमने कर लिए complete. What these real numbers are, now understand. When I talk about number line, then I'm saying that this is 0, this is 1, this is 2, this is 3, this is -1, -2 and okay, approaching positive infinity and approaching negative infinity. Now answer one question of mine. 0 और 1 को तो हमने mark कर लिया, but what about the numbers which are between 0 and 1? That is, what about the numbers 0.01 or 0.05 or in that case 0.5? What about these numbers? What are these numbers? Where to include these numbers? All these questions. Didn't these questions arise in your mind that what actually are these numbers and where I need to include these numbers for that sake and for that matter? So anybody who wants to answer. Okay. Obviously, if you people are going to answer, I'm not able to hear that. So, okay, let me only tell you, these numbers are what? These numbers are your real numbers. So, we take these numbers which are between any two, you can say, integers as real numbers. Now, real numbers also include your integers. They also include your natural numbers, your whole numbers, your negative stuff, your decimal stuff. All these things comes under what? Your real numbers. So, you can say real numbers is like the supreme power here. Okay, so let's move forward. Okay, so now the following operations of addition, subtraction, multiplication and division are valid for both whole numbers and real numbers. And for any real or whole number ABC, these are the properties which you need to remember. Now the thing is, these properties are one of the very basic properties which you people have already done in your 9th or 10th class, or as far as I can say, even in your 7th or 8th class as well. It's like commutative property, associative property, distributive property, simple properties. What is commutative property? Okay, let's review. What is commutative property? It's nothing but a plus b can also be written as b plus a. Obviously, 3 plus 2 can also be written as 2 plus 3. 3 plus 2 is 5. So 2 plus 3 also needs to be 5, right? You just have changed the order in which they are, adding. You didn't change any sign or any number or anything in that matter. Similarly, when I say associative property of addition, in associative property of addition as well, you are saying that A in addition with B, when I do initially, this bracket means that first of all, you're doing A plus B. And then you're adding C to the addition of A plus B. So I can say it as that as well. Like suppose I have 2 apples. So A is your apples, B is your banana, and C is your, okay, I cannot remember anything, but let's suppose C are oranges, okay. So let's say I have 2 apples and I have 1 banana and I have 3 oranges. Now my mother is asking me that how many total fruits I have. So obviously if I'm going to add apples and bananas first, that is 2 plus 1, 3, and then I'm going to add number of oranges to it, that is 3. So my total fruits are going to be 6. And in fact, in that matter, if I'm going to add number of bananas and number of oranges before adding number of apples, then still the addition of all these things are going to be 6. And in other matter, if I'm going to add number of apples and number of oranges before I add number of bananas to it, in that case as well, the addition is going to be what? The summation is going to be 6. So this is nothing but this is what your associative property. And the same for commutative property of multiplication says that A into B is nothing but B into A. 3 2s are 6. 3 2s are 6 means when I multiply 3 2 times. So it's sorry, not 3 2 times, but when I multiply 3 by 2, then my answer is going to be 6. And for other matter, if I'm going to multiply 2 with 3, then my answer is also going to be 6. Okay, and then the associative property of multiplication comes that A into B multiplied initially and then afterwards C is multiplied with it actually. So it will yield the same result as when I multiply B and C first and then multiply C with it. Okay, then comes your distributive property of multiplication. So what does your distributive property of multiplication says? It says that when you are actually adding A plus B and multiplying C afterwards, this is nothing but this is going to be AC plus BC. Now this is nothing but you just have to open the brackets. I hope you people have heard of BODMAS. Okay, so you just need to do BODMAS here. It's simple. Then is subtraction and division are defined as the inverse operations to additions and multiplication respectively. It's simple. Okay. So if A plus B is C, that means obviously from here I can say that C minus B is going to be A, this. And if Q is nothing but A by B, then obviously B multiply by Q, because I can do cross multiplication here. So B multiply by Q is nothing but A, where B is what? B is a non-negative number. Sorry, not non-negative, but non-zero number. Now division by 0 is not possible since there is no number Q for which BQ equals a non-zero number. A if B is 0. Again true, you people all also know that you cannot, divide anything by 0. Okay, and in fact that matter, that division by 0, it's just not possible. You cannot do division by 0. So I feel all these concepts are very, very simple and there's nothing much to do in these things. You just have to read it, okay, and just solve the questions. So let's see if there are any questions which we can do regarding this. Before that, we have the concept of your rational numbers and your irrational numbers. So before that, let's see what are your rational numbers and let's focus on that. So what is a rational number? A rational number is defined as a number of the form A by B, where A, B are integers and B is a non-zero number. So what's a rational number? A rational number is basically defined as a number that is of the form A by B, where B is obviously non-zero, because just in the previous slide we have studied that division by 0 is just not defined. You cannot do division by 0. So if B here is 0, then the whole concept actually doesn't make any sense. Okay, therefore B is actually a non-zero number. Now rational numbers are the non-integral, will have decimal values. Okay, which means that rational numbers are basically not the integer parts. Okay, they are not the one like which have the integral part. They are the ones which will have your decimal values as well. Okay, so those numbers are what? Those numbers are your rational numbers. Now these values can be of two types. They can be terminating ones or finite or non-terminating ones. Okay, now terminating ones are the ones जो terminate हो जाते हैं. What do you mean by terminate? Terminate means which can end. That's why finite term is used in this. Okay, that's why the term finite is used in this. So which can end. For example, 17 by 4 is 4.25. So obviously it's ending 0.25. After 5, nothing. It's ending. Okay, similarly 21 by 5 is 4.2. So it's ending. So these are what your terminating decimal fractions. Whereas in your non-terminating decimal fractions are the ones which do not terminate. Now when I say do not terminate, then there can be two types of non-terminating decimal fractions. And what are these? These can be a non-terminating or periodic ones, or non-terminating and non-periodic ones. Now understand what's the difference between two. Both of them are non-terminating. That means they are not ending. But what's the difference is that in one, your portion is repeating, whereas in other, your portion is not repeating. Simple. Like for example, in your periodic fraction, the portion is again and again repeating. This portion which I have underlined, This portion is coming here again and again. So from here to here, then from here to here. So this portion is your repeating. Whereas when you see in non-terminating fractions, the portions aren't repeating. Okay, they aren't repeating. So therefore we say non-terminating ones. Now, of the above categories, terminating decimals and non-terminating periodic decimal fractions belong to the set of rational numbers. So yeah, this is one of the more important thing that you need. Just write it down in your notebooks if you people are copying anything. I hope you people are, because all these concepts are very, very important, and obviously if you are solving anything, then these things are important. So what they are basically is, what is the meaning of this is that your terminating decimal fractions and your non-terminating, not fractions but yeah, so terminating decimals and non-terminating periodic decimal fractions, they basically belong to what? A set of rational numbers. Okay, so this is basically what it is, and I hope this concept is easy and you people have understood what this concept is. So next is, what are your irrational numbers? So irrational numbers, what are these? Now, fractions that are non-terminating means they are never ending, they are non-periodic. So that means they are not ending and they are not repeating. These are the irrational numbers. Okay, now some examples of irrational numbers can be root 2 and root 3. Okay, in other words, all the square and cube roots of natural numbers that are not squares and cubes of natural numbers are irrational numbers. So what are irrational numbers? Irrational numbers are the numbers which are your non-terminating one. On first, they are non-terminating, and second, they are non-periodic. Okay, so those ones are what? Those ones are your irrational numbers. And all the squares and cube roots of natural numbers which aren't actually the squares and cube roots of any number, or any number in that case, you can say natural numbers, are what? Your irrational numbers. So other irrational numbers will include what? Your pi or e and so on. Okay, now every positive irrational number has a negative irrational number corresponding to it. Obviously, if I have root 2, I will obviously have what? I will have negative of root 2. If I have root 3, I will obviously have negative of root 3. Okay, so every positive irrational number has a negative irrational number corresponding to it. Then all the operations of addition, subtraction, multiplication, division, all these applications are applicable to rational numbers and are also applicable to irrational numbers. Basically, what they want to say is that all these operations which we people use, by operations I mean what? I mean your addition, subtraction, multiplication and division. So all these operations are also applicable to your rational numbers, and all these operations are also applicable to what? Your irrational numbers. Correct. Yes, so we were basically studying what? Greatest common divisor or highest common factor, which is also known as what? Your HCF. So HCF is nothing but your highest common factor, and GCD is nothing but your greatest common divisor. Now what you need to do is, you need to consider two natural numbers. N is given, so let's say it's N1. So instead of N, just say it's N1, and this is your N2. Now if the numbers N1 and N2 are exactly divisible by the same number, say X, then X is nothing but the common divisor of N1 and N2. I feel this is simple. Okay, now the highest of all the common divisors is called your GCD or HCF. So highest of all the common divisors is nothing but your greatest common divisor or your highest common factor. So obviously the name itself suggests what it means. Okay, this is denoted as nothing but GCD N1 comma M2. Sorry, not M2 but N2. Okay, so now we know that what is GCD or what is HCF. Now let's figure out how to actually find what is GCD of two numbers or what is HCF of two numbers. Okay, so this is how you people do it. So these are the steps. So what you need to do is find the standard form of the numbers N1 and N2. So I have to write the numbers in standard form. Then is write out all the prime factors that are common to the standard forms of the number. Raise each of the common prime factor listed above to the lesser of the powers in which it appears in the standard form of the numbers. Then the product of the result of previous step will be the GCD of n1 and n2. So let's take an illustration. So we need to find GCD of what? These three numbers, 150, 210, 375. That is your 375 and 210. So what I need to do is I need to write these numbers in standard format. So in standard format, obviously 150 is going to be 5 multiplied by 5 multiplied by 3 and multiplied by 2. Okay, and 210 is going to be this and 375 is going to be this. So what is step 2? Step 2 is write out all the prime factors that are common to the standard form of n1 and n2. So common to this is nothing but 5 to the power 1 and 3 to the power 1. Here it's not 51 or 31 actually. Here it's 5 to the power 1 and 3 to the power 1. Okay, so 5 to the power 1, so I can say 5 is common and this 3 is common, correct? So 5 to the power 1, obviously 5 one times and 3 one time is common to all of this. Now the third step says that we need to reduce the exponent term to the lesser of the number which is there. So obviously 5 is occurring one time, so it's the least one here, and 3 is occurring one time, so it's the least one. And the fourth one is the product of them is going to be your GCD. So their product is nothing but, their product is what? 15. So that is the highest which we will get. Correct? So I hope this is easy. You people understood this. So obviously we have done what is your GCD or HCF. So let's see what is LCM, that is least common multiple. We have done the highest common one. Okay, we have done the highest one. Let's do the least one as well. So what is your least common multiple? Your least common multiple, let's suppose n1 and n2 be the two natural numbers. So it's n1 and n2. And the smallest natural number n, that it's exactly divisible by n1 and n2 is the least common multiple of n1 and n2 and is designated as this. Simple. Okay. And let's see how we people can actually find out the least common multiple. So these are the rules to actually calculate the least common multiple. Okay. What we need to do is find the standard form of the numbers. Easy. Write down all the prime factors which are contained in standard form, either of the numbers. Easy. Then raise each of prime factors listed above to the highest of the power in which they appear in their standard forms of the number n1 and n2. Again easy. And the last is we need the product of the result of the previous step. So this is how we do. We know what are the rules, like not rules but the steps to actually find HCF, and now we also know the rules how to find LCM. And this is the illustration how we basically do it. So how are we supposed to find the LCM of it? It's simple. What we need to do is, suppose these are the three numbers and I need to find the LCM of these three numbers. So what I'm supposed to do is I will write it down in standard form. Then I will take all the numbers which are appearing. Like for example 5, 5, 5 are appearing. Okay, write down all the prime factors actually. Okay, that are appearing at least once in all the three. So 5 is appearing. Okay, then your 3 is appearing. Then your 2 is also appearing. So 2 is also appearing. Okay, correct. So this is basically what is happening here. And then what I need to do is raise each of the prime factor to their highest available power. So I need to raise them to the highest available power. Now, if I go to my previous slide here, what they were saying were write out all the prime factors which are contained in standard forms of either of the numbers. So what I need to do is I need to actually take from either of those numbers. Okay, I need to actually write which have actually appeared at least one time. Write down all the prime factors that appear at least once in any of the numbers. Correct? Yeah. Okay. Yes. So what it's going to be, this is nothing but this y implication is nothing but it's multiplication. It's some error or something. So it means multiply. I'll write it again. This y is nothing but it's multiply. Okay. Correct? Correct. So what you need to also do is then you have to basically multiply them. So when I'm going to multiply 2, 3, 5 and 7. Okay. So 5 3 times and 7 1 times. Okay. I'll write this again. Here the prime factors which we were taking the prime factors 5, 3 and 2. Oh no, wait a minute. We also have 7 here. So we need to take 7 as well. Okay. 7 is not written here, but we have to take 7 also. I did not see 7 there. I'm so sorry. We were doing it all wrong. 7 also has to come. Okay. So 7 came. Now what I need to do is I need to find out the highest power of these. Now 5 came to the highest. How many times? 3 times. Because you can see like here. 1, 2 and 3. So 5 came how many times? 3 times. So 5 to the power 3 in one go. Okay. Then 3. 3 came to the highest one time. So 3 to the power 1. 2 also came highest 1 and 7 also 1. So 2 to the power 1 and 7 to the power 1. So I'm going to multiply all these 3, which is to say 5 to the power 3 into 3 to the power 1 into 2 to the power 1 into 7 to the power 1. And this whole is going to come what? 5250, and this is what? This is my LCM. Okay, so LCM of numbers is nothing but 5250. Now this is one of your rule, that your GDC of two numbers multiplied your LCM of those two numbers is nothing but the multiplication of those two numbers. Okay, this is your rule. So what does your rule says? Your rule says that if I have GDC of any two numbers, say x and y, and if I multiply that GDC with LCM of those two numbers, which is to say x and y, then this product of GDC into LCM of those two numbers x and y is nothing but the product of those two numbers, that is your x and y. So this is one of the rules which you need to note down because it's very, very important. Correct. So I hope you people understood that what is LCM, what is HCF, what are the products and everything. I hope you people have understood, right? So let's move forward. And we are on the concept of your co-prime numbers. So we are on the concept of your co-prime numbers. So what are your co-prime numbers and what are some of the properties of co-prime numbers that we are going to do now? Okay, it's very, very simple that what are co-prime numbers. So let's see. Now two consecutive natural numbers are always co-prime numbers. Example 5 and 6, 82 and 83, this and this and so on. Why? Because 5 and 6 है कुछ common नहीं है ना. 5 and 6 ka, if I say why are they co-prime numbers, this is one of the properties of co-prime numbers. Okay, that if I basically have any two natural numbers and they are consecutive in nature, then those numbers are going to be what? Those numbers are basically going to be your co-prime numbers. Okay, so I hope you people are understanding what are co-prime numbers, because actually what are co-prime numbers? See, co-prime numbers are pair of numbers that do not have any common factor other than 1. So that means if there are any two numbers that do not have a common factor which is other than 1, that has to be co-prime number. And that is the reason why this property arises in the first place, that two consecutive natural numbers are always your co-prime numbers because they do not have any other factor other than 1. Correct. Okay, next point says two consecutive odd numbers are always co-prime numbers. So what is the meaning of this? This means that two consecutive odd numbers क्या होंगे हमेशा co-prime number. That is if I take 7 and 9, क्योंकि हम co-prime numbers की definition से जाए ना कि factor other than 1 होना चाहिए. So obviously 7 and 9 do not have any other factor other than 1 common between them. That is why they are what? Co-prime numbers. Then is two prime numbers are always co-prime numbers. So these two prime numbers are always co-prime number again. Then one prime number and another composite number such that the composite number is not a multiple of prime number are always co-prime number. For example, these. Now the thing is, obviously you can understand these property by taking a real life example. Like you can take examples of numbers and then you can pair them and you can actually find that all these properties are true. What you people need to do is, I'm explaining these properties to you right now. The thing is that these properties are very, very easy. You do not have to do, very, very long analysis of these properties. What you just need to do is, if you're not able to understand what these properties are, you have to take just an example. You have to apply these properties to those examples. And if they satisfy, obviously these properties are true. And nextly, what you need to do is, you have to learn all these properties. The thing is, in your examination, any kind of question can arise. And if you have these properties in your mind, if you know these properties by heart, then it can actually be a very handy tool. Okay. Now your fifth property is two odd numbers with a difference that is equal to any power of 2. Okay, is what going to be your co-prime again. and these are your examples. Then two numbers that have a difference of 3 but are themselves not multiple of 3, for example these examples, they are also your co-prime numbers. ठीक है, तो यहाँ पे जितने भी एग्जाम्पल्स दिए हैं, सपोज इफ आई एम टॉकिंग अबाउट प्रॉपर्टी नंबर 3 और इफ आई एम टॉकिंग अबाउट प्रॉपर्टी ऑफ नंबर 5 से, and I have provided you with the examples, you can actually see that the property which I am talking about is applicable on the examples. And if you do not want to trust on the examples which are provided by me, you can take any other example of your own, and then you can see that yes, these properties actually work. Okay, next, so next we are going to talk about more properties. So property number 7, what does property number 7 says? Property number 7 says that 3 consecutive odd numbers are always co-prime. So 3 consecutive odd numbers are always going to be your co-prime. That is, for example, these numbers are always going to be your co-prime numbers. Then 3 consecutive natural numbers with the first one being odd, those are also going to be your co-prime, and you have to note that these are not co-prime. Okay, what they are basically saying is that 3 consecutive natural numbers with the first one being odd, like 15, 16, 17, 21, 22, 23. So what is this? These are what your co-prime numbers. You can note that 22, 23, 24 are not co-prime. Why? क्योंकि जो first number लिया है that is not odd. तो ये वाली जो property है ये fulfill नहीं हुई, so that's why they are not your co-prime numbers. Okay. Now 2 consecutive natural numbers along with the next odd numbers such that the first one is even, these can be your co-prime, like 22, 23 and 25. Then your 52, 53 and 55, and your 68, 69 and 71 and so on. Now you have to note that this would not be true in case of first, and last number would be a multiple of 3. ठीक है, क्योंकि 3 आ जाएगा ना फिर उनमें. Correct. Now 3 prime numbers, if I talk about these 3 prime numbers, they are what? Co-prime numbers, because other than 1 there is nothing between them. Okay. Then 2 prime numbers and 1 composite number such that the composite number is not a multiple of either of the primes. Like for example 23, 31 and 42, 17, 23 and 28, 13, 23 and 27 and so on. Correct. Next is 3 odd numbers for which the pairwise difference for each of the 3 pairs of numbers taking 2 at a time is a power of 2. And what are the examples of these? The examples are 25, 29, 55, 63, 71 and so on. So this is done. Okay. So I hope you people understood that what actually are your co-prime numbers, what are your natural numbers, whole numbers and all the other stuff which we talked about right now. The only thing is that I know this chapter has a lot of theory, and this chapter actually requires a better understanding of each and every point which we just talked about. So I want you people to go to EduRev website and do all the questions and everything. Okay, so just attempt all the documents and everything. Thank you very much.